will ask, good. All of you what your operating systems are.
Mac. Ubuntu.
Great.
Well, I'm on Mac, but I'm on a virtual machine.
Ah,
I'm on Ubuntu.
okay. Ubuntu is easiest. So
I have Mac
what?
OS.
Sorts of. So it's deb-based or RPM?
Not sure.
Okay. Okay. Some of the people online also said something. Maybe just write it in the chat. Okay, Ubuntu on Windows and Mac OS. Okay, so what I'll do first is I'll open the README. So I'll first actually say how you get this. So if you go to my website, then you can download Trajectum by clicking this link. So if you are on Ubuntu, you can just do this, and that installs everything. So for people on Ubuntu, it's a one-line command. It's this.
You sent on the Zoom chat.
Oh, yes, I will just post it there. So just let me know if this has worked. I'll just give you guys a minute to see whether this works.
You mind just sending it again because I just.
Oh, yeah, because you joined after.
Okay.
Now you have it?
Yes.
Oh, and by the way, the logo you see, and that you can also see on the back of my laptop, I did print more stickers. So if you want if you want a Trajectum sticker, then you can.
What? Did it work? This only works on. Or it's only works on the next these two ones. I can't do this on Mac, right?
No, you cannot do this on a Mac, but you can get the source code. So all the other instructions are in the source code. If you download it, then there's a readme.md file. So for the people on Ubuntu, is this working?
I'm still trying to join the Zoom. Sorry.
Okay. While this is happening, I'll take the stickers. I mean, I flew them all the way to South Africa.
When did you make this logo? I think the last time I was on this website. This logo. This new logo or?
It's new, yes.
Very nice.
So I have a couple. I have one and
There are a couple.
I printed 50 at first, but then people quickly ran out of the 50.
Very easy to say yes.
Well, I spent a lot of time making it. So.
Yeah. Okay, it is downloading. It's going to take a few seconds.
It should be only 10 megabytes, so shouldn't take that long.
It told me that 954 megabytes of additional disk space would be used.
Oh, you're doing the sudo apt install.
Yes.
Yes, that's the dependencies.
Okay.
But for you, this is also the only instruction for the compilation, because you're going to be done after this. Yes, I love Linux too, but not everyone agrees.
I'll see that.
Okay, so I think I'll just try to move on. So for the people who are not on Ubuntu, did you manage to download the source code?
Yeah.
Okay, great. So just open this readme.md file. So if you have the right Chrome extension, or there's probably something similar on Firefox, you can just have this render nicely. I mean, it's also human readable if you don't do this, but reads a bit nicer. So just open this README file. And then, well, I'll just, since you're not going to be able to do anything until you compile it, let's run through the compilation. So basically what you need is, you need all of these libraries. Yeah, so you need a compiler, which is new enough. You need eigen3, you need GSL, and you need HDF5, and then all of the other things we're going to compile ourselves. So if you're on a Mac, you should well, make sure that you, I think you can do this with brew. So with homebrew, you just sudo brew install, I think it's just eigen3, and then the same for GSL and the same for HDF5. And so you should just make sure that you have all of these libraries, or otherwise you're going to get an error later on. Just let me know if anything is not working. Let me also look up those. Yeah, so it's just said brew install eigen, though this is an AI overview, so I don't know if it's correct.
I think it looked like it's eigen at 3. Or does that be eigen at 3?
Yeah, good question.
Two options, eigen at 3.
Yeah, well, try both, I guess. And for HDF5, what you need. Yeah, brew install HDF5 should also be easy. So how's everyone doing? Okay, so as in finished with
Just with the brew install stuff.
So on this side, the download speed is a bit slow, so folks are just still downloading, but they'll let you know how it goes.
Okay. Okay, so I'll just wait like 2 more minutes and then I'll go to the next step for the people who are a little bit faster. So maybe Isabel, is there, if maybe it's an idea, if there's a computer on your side that can connect to a big screen and you can just make a wired connection for that computer, then you have one computer that has a fast download speed.
Okay, let me check.
The compilation is going to be the most difficult step because you have a bunch of different people who will run into different problems.
I see for some of the dependencies that get installed, like LHA, PDF, and Pythia, and things like that. If I already have versions of these, I won't get version conflicts, right?
These are globally installed if you just do it this way. So you should, well, If you use a Pythia, that is just a library that you link to, and that library is in a specific location and not globally installed, then you won't get any version conflicts. If you globally install that one as well, then you will get version conflicts.
Because I'm thinking more in the context of was like in O squared in Alice. I mean, it also installs a bunch of libraries, like also like LHA, PDF, Pythia and stuff. And I don't know if it'll have conflict with those. Because O squared is quite finicky. It's quite.
And one thing you can also do is so what you can also do is not globally install this. Then you're always going to have to do LD library path such and such. By the way, you said you're on a virtual machine Ubuntu, right? Is O squared also on the virtual machine?
Yes.
Okay, so otherwise it would be an easy
Yeah, no,
easy
it's,
fix.
yeah, no, O squared is also, I mainly use it for O squared, but I mean, it's almost done installing, so I guess I'll find out.
I think if it were to overwrite files that you already have, it will refuse the installation. So I think it should not get you into any kinds of versioning conflicts.
It didn't seem to complain about it. Successfully installed everything.
Then it should work. So if you type in a terminal, just collide and then nothing else, what happens? Yeah, that seems to do the right thing. So you have successfully installed Trajectum.
Okay, there's LHA, PDF, Pythia.
Yeah, so for legal reasons, it prints all these banners.
Okay, I see. Because you use those packages and.
Yes, and some of those packages, well, so at first I tried to just not print any banners because it's cluttered your screen, but then in the place in one of the packages where the banner is printed, it says in a comment like, it's not in the spirit of open source software to not print this banner, so you cannot suppress it.
Yes.
So, well, I'm not just going to print the banner of just one dependency, so then I just printed all the banners to pretend that it was the intention. Okay, so let's move a bit further on. I don't know how people are doing in installing in the brew install. Okay. You're on Mac or Windows? Oh wait, you're on something GNOME based at least. So so you don't have so you cannot use this.
Yeah.
So you're just make sure that you have those.
We don't need that. Well, I think
So can you just search online for the name of your operating system and then DNF? I've never heard that. So what you're gonna have to make sure is that you know how to on DNF get these packages. So you need to get the development files of Eigen3, GSL, and HDF5. So I don't know how these are called in DNF, but it's probably just Googling DNF and then the right library, and then it'll tell you what to do. Okay, so I'll move on to this. You're not going to need the optional prerequisites unless you want to do some really exotic stuff. So first, we're going to have to compile LHA PDF 6. So you just click the link in the README file, and then that downloads it. So I'm going to let you do that. And then you can see through the magic of packaging, you don't have to do this.
Yes.
Does cause me a lot of pain though, because I have to make the packages and you have to make sure it compiles for every single Ubuntu version and every single, like you're not on an x86, you're on ARM architecture. So you have to make sure it also compiles for that.
Yes.
quite difficult because then sometimes you get compilation errors, but then, well, I don't have an ARM. Well,
Okay, so you
I
can't
have ARM
reproduce.
architecture, but it's here.
So it's hard for you to reproduce the error and see what's going wrong.
Also, sometimes if people come with very strange bugs, then it's like, yeah, seems to happen on your machine only, not on mine. So, okay. So did everyone manage to download LHCPDF? Okay. So just unpack the tarball. And then in the tarball, you create this build directory. And then you run this command. And you need to be smarter than ChatGPT and realize that /path/2/LHCPDF should be replaced by what the path is on your computer. Was once a student who was following this README, but he didn't actually read the README. He fed the README into ChatGPT and then asked ChatGPT to help him. And then ChatGPT correctly sort of read that it was supposed to do these commands, but then it didn't read under this thing, like where one should fill in the appropriate path. So ChatGPT didn't get that correct. Okay, so and once you've done that, you should just execute make and make install. So if you have multiple cores, you can also do make. For me, it would be make -J16.
I put this LHA PDF file somewhere, folder somewhere that it might live for.
Yes, you need to make sure. Well, yeah, you need to make sure that it is. It needs to remain there permanently. So how far along are people in this?
I'm not sure if I'm in this.
Oh no, you shouldn't DNF install that because I don't have those. I don't have DNF, so I haven't made these packages. But what I mean is that you should first download the README. So download the code.
Yeah, download.
Yes, and if you have README. Get that. Okay. You don't have tar. I don't think so. Does this pseudo DNF install tar? Okay. Just right click it and. No extract. Oh, wait, you already extracted it, right? You already did so, right? Speak double click, yeah? Yeah, here. Now, so just open the README. Yeah, so these three libraries, so this is sudo apt install this stuff, but you don't have apt, so you should really do sudo dnf install, if that's the syntax. And then probably these library names are not going to be exactly the same, but you can see whether it works. Yeah, so it doesn't find them, so they're probably called differently in DNF. So you should just Google something like DNF install icon 3, something like that. Like that. Oh. Yeah, so you made a build directory, so you're supposed to cd into it. Or do you okay, so you go into I think so. Oh no, not you don't cd into it. Okay. I trust my own readme. So no, you stay in that directory. Okay. UPVD. Okay. Yeah, so now here you execute this /configure -- prefix equals
Right, that was giving me an error, so. Yes.
but you call the path, right?
Yes. So
So what error does it give you? /build.
oh,
No, wait, English. No, you're not inside build. I think you don't seem to be in the right. On that. Yes. Yes. Yeah, this looks better. Okay. So it says you don't have a working C++ compiler. I think on Macs you're supposed to make sure Xcode is up to date, but I'm not completely sure how exactly to do that.
okay.
I think for Xcode, you just have to go to the App Store and go update it there.
Yeah. Do you have Xcode? Sure, because it says, I mean, the C++ compiler requirement is quite old. So even if it's old, it should still work. So this really looks like I really don't have the C++.
Yeah.
So probably you don't have Xcode installed at all. Possibly. Yeah, so just go to the App Store and just install it.
You will Xcode.
I don't remember. Yeah, I missed it, but I mean, in mine school, fine. I go GCC.
Did you just manually install GCC?
I don't know. I mean, that's great. That's here.
Probably installed it.
At some point, I need it.
Good. So an item 3 also managed?
Yeah.
Great. So now you should be on what you can now do the same steps. So you can get this LHA PDF6 downloaded from the link in the README and then follow those steps. How's everyone doing online? No response. Am I still connected? It said my internet connection is unstable, but okay, good.
Just scroll and I'll see it. Yeah, yeah.
Okay, good.
Sorry, can you hear me? Hello.
Yes.
Yes. Can we please have the README file?
What do you mean?
Can we browse it through on our
Yes.
local desktop? Yeah.
So are you in this step?
Yes.
Good. So are you guys on that side managing to do this?
It's still running.
Okay, so you're on make.
Yes.
Okay. Oh, no, we're at CERN. Oh, it's cool. Oh, it's still downloading. Yeah, it was a bit more difficult than I thought it would be. So also these two things are quite large. So if you're doing some other step, but you're not using your internet connection right now, maybe you set these things to download already, just to save some time.
Okay, that
Is it okay to use what?
that
I think so. It depends what version.
Oh.
So what version is offered?
6.5.5.
Oh, that seems perfect. So if you can just do that, that's probably easiest. So yeah, some of Trajectum's dependencies depend on specific versions of things, so that you cannot. Well, you really have to have that specific version, otherwise it won't work. It won't work for reasons I don't know. I don't know why they depend on that specific version, but well, if the authors of those dependencies tell you to do a specific thing, then I just do it. Okay, so where are people now?
Still the configure. I as well. I've just been going through the installs.
Oh, so you're further than
Yeah,
yeah.
it seems like it's all pretty much the same. The posture.
Yes, I wrote everything down in a way that you can in principle just continue. You don't have to wait for me.
It's just run.
So the configure runs without her, or
I think.
what?
Literally once.
Yeah, I guess so.
Beauty of the Bluetooth.
We're not use it until
You can see, I guess you got a version. Yes,
And for you, if
you ever get your hands on a
the
virtual machine, you should say
yeah.
I'll go into virtual.
Yeah, so in principle, you have all the libraries, you can just download
You just use
them.
that. Yeah, but the problem is in HPC, you don't have like permissions and stuff. You can't just install things. Yeah, you can't just.
So, oh, you mean installing this in a cluster?
Yeah. Yes.
Oh, I should tell you about this. So there is in the source code, if you go to the examples directory, then inside that directory, there's an LX plus installation directory with a separate README that tells you how to compile this on a cluster, or at least how to compile it on LX plus, which is the CERN
Yes.
cluster. So since people are working on stuff anyway, I can just tell you this does so. So yeah, it basically just has a separate README, which, well, just has download links for everything. And then it also has, so it has, for example, compile LHCPDF. It has, well, just a script that you can just run. So you just run all of these things in order. And then what it does is it creates this, well, you create this copy to node directory. And then inside that copy to node directory, once you've run all these scripts, it puts all the executables and all the libraries that are needed. So then if you make a job, then you just need to make sure that all the contents of this copy to node directory are copied to the job, and then it can run. The only thing is that the all of the versions of software on most clusters are really, really old, as in start of the Iraq War old. So you need to do this CVMFS trick to trick the computers into thinking they have newer software. But then you might need to fiddle around a little bit with these version numbers and with the GCC versions, because sometimes it just doesn't compile for reasons unknown to me. And you need to, well, do a bit of manual labor to figure out the correct these correct versions, where you should be very careful that you need to do these source commands consistently throughout every script. So that if you're running LHCPDF, for example, say you have to change this 108 to 107 because for some reason 108 doesn't work, then you need to change it to 107 everywhere. And also when you run any of it, you also need to make sure that you source the same things again. Otherwise, it won't link to the correct libraries. It's a bit annoying, but it does work.
This is because the CERN cluster is distributed. I mean, whenever I run a cluster job, you don't need to like copy things to the on this cluster. Or is it because CERN is like this distributed cluster? Or?
It depends on the cluster's architecture. So at CERN, for example, the architecture doesn't have very strong connectivity. So you can't go copy a bunch of large files. So for example, at CERN, you would need to always use this EOS copy, which is better able to handle this somehow. I don't know exactly how it works internally, but so basically, if there you just try to copy 1,000 files to 1,000 jobs, then an admin gets very angry at you because you crashed the cluster. So it depends on your cluster. I mean, there's also some clusters where you can just not copy these things at all and just leave them in a certain place, and then every job just has access to a single shared directory structure. But that usually requires better connectivity between the nodes, because then they need to, well, be integrated to such an amount that they have a shared file system. That does bring other challenges though, because then you need to make sure, like, what the nice thing is about having all jobs have their own file system is that you can have basically the same file names for every job separately because they don't interfere with each other. But if they have a shared file system, you have to take care that the files of different jobs don't overwrite each other. And so both architectures can work, but they all have their challenges.
Yeah, sorry, I must have I got managed to get the install the spine.
Yeah, so what's its output now?
No.
It still doesn't look okay. Oh yeah, so you get the error that it says cannot find path on your system path. Then you need to add this option. Okay. I think the sensible thing to do would be just to when it detects that you don't have the right Python version, to just add this automatically. Okay, so for people who are a little bit faster, perhaps like the next step would be to download FastJet, which you download by clicking this link, and you do the same thing. So you create a build directory, you run this command where you make sure that you get the correct path to this build directory, and then do again make install. And then the next step, so Pythia depends on both of these things already existing. So you really have to finish those before you start working on Pythia.
I'm on the Pythia server. I got this error.
So you're doing Pythia right now, or?
I see it. It is slash build.
What did you do?
Yeah, I think I installed the slash build on these. So yeah, I thought Pythia. Right.
Yeah, I can find it. So make sure you clean everything up before we start it, because otherwise you might have a problem. Just make clean should work. So actually, if you do make, you can also, if you have multiple cores, you can speed it up by doing. So if you just do make minus J 16, for example, I don't know how many cores you have. We should figure it. Like that. I think. Well, I always do without the space, but I don't know if it works if you do have the space. Yes, so yes, you can check it out and also make the terminal. So how many cores do you have? Six. So to make a space.
Everything goes right, you feel really cool. You feel like I can go faster, then you use all your cores.
So for you're on.
It's useful. Yeah, well done.
So now, since I think all of you are in executing make commands, right? So you're all basically waiting.
Yeah, I
So what I'll then do is I'll go through the source code a little bit with you or things you can find. So there's these examples which we're going to get to hopefully if you guys install everything in time. That are all basically worked examples. So you can just, if we go into one of them, they all have a README that you can read, and they should all, well, so the requirements are all there. So it says like how much time it takes, at least on this laptop, how much RAM you need, how much storage you need. So we're going to get to that later. It's annoying about Zoom that I cannot actually navigate my browser. Another thing that there is the par files directory. So Trajectum uses parameter files to run, and all of these parameter files for different for every paper that we ever wrote with Trajectum, the parameter files are included in the code itself. So if you want to reproduce results from a particular paper, you can just, well, these are obviously archive numbers, so you can just go to the correct archive number and then get what you need. So if I go to, for example, this one, you'll see that many of them have file names that are sort of numbered. And I don't know if you've ever seen in any of the Trajectum papers that we have these systematic uncertainties from parameter variations. You've seen that before? So how we make those is that you have this Bayesian analysis, which I'll say in the colloquium tomorrow. So you have this Bayesian analysis that gives you an ensemble of likely parameter sets. And then we just draw 20 random samples from that. And if you run Trajectum with those 20 random samples, so random parameter settings, you get 20 different predictions for whatever observable you're making. And then if you look at a band that is formed by all of those predictions, that gives you your systematic uncertainty. But so all of these parameter files, so these 20 different ones are given. So you can in principle even run all 20 of them and then make your own band. So another thing that I'll maybe say at this point already is that for the observables, so Trajectum basically consists of three main programs. You have Collide, which actually runs your events. Then the output of the events goes through Smash as an afterburner, which is not actually part of Trajectum, but we use it. Then you have an Analyze, which basically runs through every event and analyzes what you want. So if you, for example, say, I want V22 computed, that's what Analyze will do. It will compute all of the event by event quantities that are needed to compute the V2. And then you have Collect, which takes the output from Analyze, because Analyze outputs event by event stuff. Then Collect looks at, for example, okay, I need to sort all of these events into centrality bins. So that's what it does, puts everything in the right bin. And then for every bin, it starts making the event averages and then doing like the final stuff. So in the case of a V22, for example, you take this average of 2, you average it over all of your events, and then you have to take the square root. So that's what Collect does. And then that also computes your statistical uncertainties for you in an automated way, generates axis labels, etc. But so for this is the parameter file that's used for Analyze. There you see that you can for example, here you can specify different centrality definitions. So I don't know how many of you have seen this paper that Wilke and I wrote about the speed of sound. So basically, it's that this observable depends a lot on the centrality definition. So this is how we computed that you can just say, for example, this one is, well, we gave it the name Alice TPC, which is basically the acceptance of the TPC in Alice. And then you can also have this, well, this other thing that Atlas likes to call M_AC. And so you can have as many of these as you want, and then it will, well, make these available to you. And then every observable is basically, well, it's sort of like a C++ struct. So it's basically, you have a name of the observable, and then there's parameters. So if I take, well, maybe if you want to do the mean PT of psi baryons, then it wants from you, for example, your lower PT cut, upper PT cut. So you can put all of these things into the parameter file, and it will automatically be used in the correct way. And all of these observables or at least we try to do our best to make the observables as close to how the experiment measures them as possible, so that it's apples to apples. And then for collect, you have a parameter file which, well, you need to give it things like what are the centrality bounds, what are the eventual engineering bounds. So if you don't use this, just set it to 0 to 100. So basically, you can specify the bin boundaries that you want. You can even buy, if I were to do this, I can say I want the 0 to 5% centrality bin, but I want the actual results to be computed in 5 sub bins, and then I want the results averaged together, which is actually how Alice does things. So it's actually very versatile in how in what you can do with it. So now let's get back to compiling. How is everyone doing? If they don't print any error messages, then they're usually successful. Then you'll know if they're not successful. Yeah, this looks fine. This looks fine. You also didn't make install, right?
Yeah.
Yeah. Okay. Yeah, good. This error. Okay. So you're compiling Pythia?
Yeah.
It looks like it's not getting the correct path to LHA-PDF. So what did you use in the configure? Here it also says disabling fast check because it says you did the same mistake as ChatGPT. I mean, it's also like I thought about how to do this, but like there's no way for me to know what this path is going to be in your machine. So I have no other solution than to write it this way.
Isn't it okay to use a backup manager to install
If it's this exact, oh no. Because you need to compile Pythia with these options that it links to. If the default version of Pythia, if you just compile it vanilla, which is really what the package manager did as well, then it doesn't have the capability of linking with FastJet and with LHCPF. So then it doesn't work. So you're retrying your.
Okay. Some of them can. Yeah, sorry. This is on.
This is what you sometimes do. If you go to the README and you scroll almost all the way down, there's. So here you can see that in the known issues section, I've made a whole bullet point of Apple issues. One of which is this.
This is.
Um, so yeah, most people are in doing Pythia. So the next thing is this Gemini. So another question, like, do you guys have Mathematica installed? Okay.
Yes.
Do you have Matplotlib?
I usually, if I do things like that, I just use like Google Colab to run.
This is one of the device, well, it's not the system that they use.
Yeah. Doesn't matter. So basically the final output of Trajectum is going to be an H5 file. And there are many ways you can read an H5 file. Experimentalists always say they cannot do it. This is too difficult. But it has H5 can be read in Mathematica. It has APIs for C++, C, Python, a bunch of other things. And there's online tools by which you can read it out. So there are many ways that you can read an H5 file. So just it's up to you what your preference is. So well, my preference is Mathematica. But if you're a Python person, then well, most people seem to be Python persons these days. So in that case, Matplotlib is your friend.
I mean, I usually do all of my analysis in root.
Yeah, so many experimentalists have asked for root output. So actually on our private repository, which you can join if you want, there is actually an open issue create native root output, which people have requested, but no one has seemed to volunteer to make it. Well, yeah, I mean, I know that it's in principle not hard, but I never use root, so.
Yes. I mean, this is an issue always in Alice as well. People will like come and they'll request things, but it's like, who's gonna do it? Who's gonna do the work? Who's gonna implement it?
Usually not the person who requests it.
Yeah, exactly, exactly. That people are always requesting, but they never want to actually do the work.
Yeah. But so if anyone volunteers, then you can make native root output for Trajectum.
I think I'll just use mine. I'll go and join to go and add my to the request.
Yeah. So one thing, like we have thought about, like now that our community is growing, we're trying to add service tasks. As PhD students have to do things like these minor things. Okay, so you don't have CMake. So that's basically just however you do this with this, it's just brew install CMake, I think. Pretty pseudo brew install CMake. I guess. Pretty pseudo, you pretty need to pseudo this. Another thing I've seen people do with ChatGPT is just copy ChatGPT's commands, which includes sudo, and then just put your password in. Okay, so in the meantime, while people are compiling, I see that there's a chat. Okay, I will oh wait. Yeah. I will show how to use Trajectum's output using Mathematica, which I know you guys, well, most of you don't have. But there are similar instructions for Python. So what I'm going to do is there's this file that I've pre-prepared. And in case anyone's wondering, yes, I do really have a folder called temporary on my laptop, and it's been there for years. Why is this not loading? I'll just give the file a name. Okay, so basically this H5 file format is basically a database format, so it has all kinds of well, data sets inside it, but there's one thing that is nice to see. So what I've also included in this, so this maybe just look at the screen for now. So there's functions inside this H5 file. So anytime Trajectum makes an output, it includes these functions in the output. So for example, for Mathematica, there's load all helper functions. And this is Mathematica code, which you don't have to read. But then in the case of Mathematica, if you just do toExpression, then it evaluates the function. So now if I say load all helper functions in this file, then it loads these functions. And it includes, for example, a help, so available observables. I misspelled that, I think. Tells you how to use it. So, and there are similar things actually for Python. So in the case of Python, you can just import this function and then execute it, and that will allow you to automatically read in all of the observables in Python. So if, for example, I want to now do something like load data single observable. Well, let's say I forgot how to use it. So here it says what I'm supposed to give it. So first the file name, then the observable name. Of course, I know this by heart, but you can look all of this up. Definitely in the README and in the examples. So say I want the multiplicity. So multiplicity charged, then the offline track definition. So that's basically how the centrality is defined. So say I want the Alice TPC, and then I want it binned in centrality. I cannot type apparently. So then the next thing is the centrality bounds. All of this is explained below, but so say I want these bins. And then for ESE bins, I'm just gonna not do event-driven engineering. Did I? misspell anything? Oh, wait, it's supposed to be some bind. Yes, good. So you can see basically when I evaluate this, there's two things. There's a labels element, and then there's a data element. So the data element basically contains what is on the horizontal axis. So that's in this case just the centrality, and the vertical, what's on the vertical axis, including the uncertainty estimation. So all gets read in automatically. And then in the labels, it basically tells you what the centrality thing is. I mean, this can also be something else. So if you're, for example, binning in, like here I have to say it's centrality binned. I could also have said ntrack off binned, and then it bins an offline track count instead of centrality. And in that case, this label would have said ntrack off. Event chip engineering label. So if there's some internal binning, so you can see there's also low data binned observable and low data double binned observable. So if I'm, for example, loading a spectrum, then it's going to be a binned observable. And then here there's going to be a label of what is the binning. And then if it's double binned, there's going to be a second label here saying what's the second binning. And well, so this is the quantity on the y-axis. Then there's what the kind of particles you're looking at, so charged particles. But if I were to, for example, say I want multiplicity charged pion, then this charged will change into pi plus minus. Then there's the cuts, PT cuts, and rapidity cuts. So all of these things are meant to foolproof as much as possible. So what I'm going to do is I'm just going to copy this. This is Mathematica syntax for basically, this is a function argument, and this is basically means apply what comes after this to here. So I'm just going to take the second element of this guy, which is this. Then if I just do list plot, it'll it's a multiplicity, so maybe list log plot. People usually do that. Then I can very easily make it into something nice that I like, well, let's first do joined true. Let's make it put a nice line through it. And frame true, and then frame label, I can just say it has to be the first element of this, and then I want 1 and 5. So I want element 1, centrality, and element 5. So then if I just do this, I get something which, well, doesn't look great. You can still do some more options to make it look publishable, but you can very easily just import what you need. And also I realized you cannot really see the uncertainties. So just to show you that they are really there. Yeah, the uncertainties are also automatically plotted. So, but then, so yeah, everything is foolproofed as much as possible. So in this case, for example, it'll also include the GEV label inside the label, so that you know in which units the things are that you're plotting. Yeah, so and also that you know what the cuts are. Because usually when people plot things, they don't show what, for example, kinematic cuts are, but they are important if you want to compare the data. So that's why basically everything is made in such a way that all of your settings that are important are actually transported to the output file, so that you can always know for sure what you did. So yeah, just for foolproofing, because you can always screw things up. And also, actually, if you there's also some security features in it to make sure that you are protected from your own stupidity, which I have used a bunch of times. That, for example, say you run multiple batches of events, say on a cluster, and you run 1,000 events, 1,000 jobs on different nodes, but then by accident, you're using different kinematic cuts on one of the jobs compared to the others. Then when you try to compute your output, it'll actually throw an error saying like, there's something that you didn't quite do right here. And it will refuse to give you to produce an output file, and it'll tell you with an error message exactly that the kinematic cuts don't match. In that way, I've tried to make it as foolproof as possible that you, at least the things that I have encountered that I've done wrong myself, you'll get warned if you do that. Yeah, so how's everyone doing with the compiling?
I'm not exactly sure how to resolve this eigentree issue. I mean, I think you said to follow this.
Yes.
Because I'm getting it when I try to install Gemini. Is it Gemini does
Yes, it does have. Oh, yes. Gemini uses CMake. Then. Yes, I know that PKG config is something specific to auto, so that won't work for CMake. Maybe just Google CMake PKG config or something. Another thing. You can always make a virtual Ubuntu machine. Just install it that way if it really doesn't work.
Yeah.
And this is also the thing with Macs that I've never so far seen people have consistent errors. It's not like every Mac user seems to be unique in how things fail.
We have the same issue with O squared in Athens, like people who install it on Mac just continuously come with installation errors.
But then, you know what the thing is I don't understand? Why do people keep buying Macs if they're like, especially if you're an lease? You know you're gonna have to do a bunch of things with installing software and then working in terminals. Why do people buy Macs?
I don't know. I think, to be honest, I must say, like, even though, I mean, I use my virtual machine for everything that's important, but when it comes to like everyday use, Mac is nice, you know, like to work with your emails.
It's nicer than Windows.
Yes. I mean, for like basic stuff, it's nice. But when it comes to actually working with like software and stuff, it can sometimes be much better than Windows.
Yes.
But worse than
Actually, not anymore because Windows made it a lot easier to have a virtual Linux machine.
Yes, for the Windows subsystem for Linux. Yeah, I've started using that as well. It's quite nice.
So you still have the same?
No, I'm not getting. I don't know why.
Did you get your issue with Gemini?
Yeah.
I didn't get it just saying.
Why are you using it?
Yeah. The CMake error.
Yes. Which is
That's maybe a question you should
Okay, so I use the package manager, so that I'm realizing that when I want to actually configure it.
Oh, you need the source files, yes.
Yes, we'll check the actual location of the LHTP file. I have it, but there's no full day inside.
No, so the important thing is that inside build, there should be a lib and new director. So that could well
Religious things will be probably easier. I just install LHP in my job.
I think it's like tree. Well, I did something in like a tree. When I was similar.
Yes, you need. I will smash. Oh no, camera. Huh?
Oh,
Why do you
in
get
the wrong spot? I think.
50 here? But, well, wait, but
Yeah, I ran the
clear
wrong.
because you
Yeah, I ran the Gemini. I think
Yeah, so if there's any,
which one?
if people are confused by the README and have a suggestion for how to make it clearer, then I'm all
Okay.
ears. Yeah, so there's all kinds of issues also with that you haven't encountered yet, I think. But so there's also one include header that got split up in the standard library. But then that means that basically newer versions of compilers won't be able to compile things anymore unless you explicitly put the include statement there. So in many dependencies, that's very annoying because people just haven't updated yet to those new things, and then I have to fix everything. Cole, can you maybe share in the chat how you solved this? So maybe while people are compiling, I will do something that I had hoped would be a bit we would do together, but probably with time we won't manage. I'll just do it on my own laptop, which is to run one of the examples. So don't worry that the directory is a bit different from what it would be on your thing. The example is exactly the same. I just modified a little bit because I don't want to work in the directory because then my directory gets bloated. So I'm working in a different directory. So I'm using this ledlet 2D narrow rapidity example. And what I'll do is I'll make it run a little bit quicker. So I'm not going to run 10,000 events. I'm going to run 500. So what I'll basically do is I'll run through a little bit of how the parameter file works. So first you have this general section, which basically says how many events do you want, if there are any NPDFs that should be used, which ones, bunch of settings. Then these things are quite nice. Wait, actually, I won't run this one. I'll just restore this thing. I'll run alt central because it's a little bit more interesting. So I'll again, well, in this case, I'll run like 100 events. So this guy is our entropy acceptance probability. And you can use this to bias which events you want. So in this case, well, the example is called ultracentral. So this is if you want mostly ultracentral events. So what you can do is you can bias that only certain initial conditions are actually computed. So you generate a whole bunch of initial conditions, you pick the ones that are likely to be ultracentral, you run hydro only for them, and then what the nice thing is we can do this in a way that removes this bias in the analysis step. So how it works precisely is that it uses the initial entropy as an estimator for the centrality. I mean, it isn't exactly the centrality, but it just correlates with it very well. At least in lead-lead. For example, oxygen-oxygen, it doesn't. But for lead-lead, it does. And then what you say, for example, okay, if this thing is really 0% central, I accept it with probability 1. If it's 0.1 central, 0.1% central, I accept it with 20% probability. You can basically get this skewed acceptance, and then what you just do is the probability with which you accepted it to actually compute the whole event. If you just do 1 over that and use that as a weight, you undo the bias. So you still get, you don't end up with any biases in your final output. You just get smaller uncertainties where you want them. Then there's also oversampling. So that is basically using the same hydro event to compute multiple sets of particles. So hydro is really expensive. So if you can, and you're sort of losing a lot of statistics when you convert the hydro to particles. So if you just compute multiple sets of particles, then you overcome this a little bit. So again, this uses this estimator of the centrality, saying, okay, if you have a 0% central event, oversample 30 hydro events, all the way to, like, if it's 100% central, 50 hydro event, 50 particle sets per hydro event. Why it's nice that you can make this centrality dependent is usually there being a finite number of particles per event punishes you more if there are fewer particles. So if you have really few particles, then this is really a killer for your statistics. But if you have an event with 10,000 particles in it, then you don't really care that much because it's going to be fine because you have many particles anyway. So you want to oversample the events with fewer particles more than you want the central events. And with this, you can do that. Also, SMASH is really slow for events with a lot of particles in it. It goes like n squared in the number of particles. So the central events are really slow in SMASH. So if you oversample the peripheral events a lot, it doesn't really cost you any extra CPU time. So you can basically get a lot of extra statistics for free.
Like randomness from hydrogen.
Yes, there's some randomness. So, and it makes sure that you don't do it in exactly the same.
Yeah, how do you know? I mean, somehow that's sort of, a lot of it sort of feels a little strange. Like, imagine you only have one hydro event, and then you resampled it like a million times. It looks like you have this amazing statistics, but it's like super complicated. Like,
yes,
when you're allowed to do that or not.
So that's why in the README section, in the README, there is a section called warnings. That if you do this, you need to be careful. So inside Trajectum, everything is taken care of that this is computed, the error bars are computed properly. So basically you need to take into account that these oversamples are not statistically independent of each other. Right? So it says if you compute your own error bars, so if you don't use analyze and collect to do it for you, then you need to take this into account. It's not super complicated, but you do have to think about it if you compute the error bars.
I also wonder, I mean, so in the context of like we work on like energy loss stuff. So there you have like a temperature profile usually, and you run your jet through it and you lose energy. I mean, that would be, so now say you get 30 events sort of because they were like these 30 different one hydrograph and like 30 different sets of particles, like then you shouldn't only treat those like one event. You want to
So
like
the
actually
way
parallel that kind of protocol.
so the way to deal with it is actually quite simple. So what you just do is all observables are in the end written as some quantity that you compute per event, and that is then averaged over all events. And then you maybe do some more math. So all you need to do is when you compute the average over all the events, then of course if you oversample, then, and it's the same as if you run a jet through the hydro background, then what you need to do is you basically replace the one event with one hydro with one set of particles, and you split it up into, say, 10 sets of particles, and you give each of them the weight, you multiply the weight of each of them by 1/10. So then you basically replace this one thing by 10 different ones. Obviously, that's not going to change your average, at least in the like a large statistic limit. It's not going to bias you in any way. So what you just need to be make sure of is when you compute your error bars by, for example, doing a bootstrap. What you need to do is after you've computed these event by event quantities that you're going to average, is first look in your centrality bin, like which of my samples come from the same hydro event. You average them together first, add their weights, and then treat them as a single event. So you basically take all of the things that are statistically correlated, and you average those together first, and then all your samples that you're left with are statistically uncorrelated, and then you can treat the errors as you would normally. That's actually also how Collect does this. So it's not super complicated, but you do have to take this into account, because otherwise, indeed, if you oversample a million times and you naively just compute your error bars as usual, then you get something that is ridiculously underestimating your uncertainties. And actually, in this context, there's also an example that specifically addresses this. So there's the generate hydro events example, which I'll explain while this is running. So I'll first go through this. There's a chat message. Yeah, you also experienced the M1 issue.
Yeah, I think that's not solved that issue.
No. Yeah, so basically, how the Collide parameter file works is that you Trajectum consists of a bunch of components. So for example, you have an initial conditions component, a pre-hydrodynamic stage component, a hydro model, transport coefficients, etc. And you need to choose which one to use. So Trajectum is not just a hydro code, it's more of a framework where you can use, well, a multi-stage model. So you need to pick all of these components. So for example, here I'm choosing, I want Trento initial conditions with a neutron skin for my nuclei. I want there to be a d-min, so a minimal distance between the nuclei. I want there to be nuclear substructure, so I want multiple hotspots in my nucleons, and I'm using wood saxonium. So you can also, for example, just put lead here. So we just write PB, or OO, it'll do oxygen. In this case, it's wood saxonium because we want to have a wood saxon with, well, being able to specify the components manually. And then you see, for example, you have nucleus A, you just specify how many nucleons it has, how many protons. So this is just lead-208. What the wood saxon radius is for the protons, skin depth for the protons, same for the neutrons. So you can also put a beta-2 in there with some standard deviation. There's a bunch of parameters relating to Trento. Then you have a similar thing for free streaming. That's the pre-hydrodynamic stage. You just specify which one, and you give it its parameters that it wants. Hydro model, which solver do you want to use for the hydro model? which you shouldn't actually touch. This one is just the best we have. The equation of state, so then, it's the equation of state plus transport coefficients. So for example, here you can see that it also has a shear viscosity, which depends on temperature. So it's basically that at 0 MeV, 150 MeV, 300 MeV, you get these different values. Same for bulk viscosity, and there's a bunch more. So basically, it has all these different components that you can use, and now I'll just set it running. So they all basically just say you just set up first and then run all, and then this will start running. While this runs, I will tell you guys how to do the this one. So this generate hydro profiles example. So Isabel made this plugin for Joule where you can use a hydro profile from Trajectum and plug it into Joule. But then the thing is, how do you then compute your RAA, for example? Say you're doing some kind of biasing or oversampling, then you need to know how to do this. So there is actually an observable, which I've called event numbers. So the base observable is basically event numbers, and then it has subs for the hydro event number and the oversample number. In this case, I haven't used oversampling, so these are all 0. And then this hydro event number, what you can basically just say, just do is you can use these helper functions that I've shown you like a half an hour ago, and then remember that this is the centrality bin. So I can just ask it like, okay, I want for the 0 to 10% bin, I want the hydro event numbers of all the events in that bin. So then it gives you this list. And then you know that, so if you do this thing where you have the Joule the output from Trajectum that's supposed to go into Joule, these are all numbered. And then the numbers that you plug in there, or the numbers that you get there, are exactly these numbers. So then you know that if I want the 0 to 10% events, then I should run Joule on hydro profile number 16, number 17, 18, etc. Just all these things. And here you can see that it's basic almost all of them, which is because this was run with a bias, right, so that you get mostly 0 to 10% events. And then what it also gives you are the weights for each of those events. So in this case, since I basically, the biasing that I used was basically flat for 0 to 10%, and then a steep drop off to almost 0, and then almost 0 for the rest, cannot be exactly 0 because the weight is 1 over the acceptance probability. So, well, cannot have 0 events with infinite weight. That's sort of a NaN situation. So here you can see that basically the way you should, when you compute an event by event average, or an event average over this, for example, computing an RAA, then you should treat all of them with weight equal to this, which, well, in this case is sort of trivial because they all have the same weight, so it doesn't really matter. But if you do something with some weight that is not flat, then you should keep this in mind. But so this observable basically can tell you exactly like which events to take, how, when you compute the averages, how to weight them. And if you are using sampling, which really for your hydro, for your jets inside a background, you're not going to want to do that. But it tells you which oversample numbers to use, which then tells you that if, for example, the hydro event numbers, if say the 16 is in there twice, once with oversample number one and once with oversample number 2, for example, then it tells you like, okay, these things are really from the same hydro event, so take that into account when computing your statistical errors.
That way for the 0.4, one of the ways is different.
Where?
Look at the first row somewhere in the middle.
Ah, yeah. Yeah, so that's one of them is apparently more likely than the others.
Oh, because it obviously came. Oh, since it came from an entropy, then you get more particles.
Yeah, so
Well, if that's probably the highest central quantum.
yeah, so I don't actually know why most of them are equal and this one is more, but I do know that it's correctly computed, so you just should just trust it and just give this one double the weight apparently. I have looked at it very carefully to make sure that it's correct. In the meantime, this guy is computing. So how's your compilation going? Maybe just make a new terminal. Now you're no longer in Git.
No, I don't think I was when I navigated to here.
Because the weird thing is Gemini doesn't use Git. So I did, well, internally, of course, I did use Git for this, but that's. Why is it? I mean, there isn't even a Git repo. Can you just do ls or something then? This is very, very strange. Is there maybe a secret Git repo or something? No. This is very strange.
Yeah.
And it doesn't actually allow you to actually do the command. I don't know. Yeah. This is very, very strange. Yeah, you can try to stop the Git service and then. Yeah, and yeah, maybe just reboot. Alright. Try turning it off the line.
So that I see it as
Yeah.
I exclusively use my I
Are you inside the go directory? Oh, you should have CD into the go directory. Yes, that was very.
You've seen this before?
Yes.
It's somehow seems like auto recomp is like replacements.
Did you ran auto recomp? No, you should not run auto recomp dash install. It's only if you're combining from Git. But now you've ruined your this configure script, so you should re-download, well, or at least get rid of this directory and unpack the. So now you see it's done with collide, so now it's automatically running Smash in different threads.
Oh, so okay, so I should just skip it. So when I read on the
Yes, you should not do the auto response.
I see. Okay.
It also says only to do this.
Right.
I did write everything down.
I believe you. I didn't read it. Because
You won't believe how often I get emails of people who get who fail to read. Is everyone in Joburg also still doing okay?
We're here, but we're all struggling.
Okay.
Sorry, Govert, it took me a while to realize. Okay, so one person here is having an issue with, so she managed to actually get pretty far in the Trajectum installation, but Trajectum is saying that it can't find the H5 header file, h5cpp.h. Where would that be? I don't see it in, should it be in the source directory for Trajectum?
Is she on, like, in which operating system is she on?
It's Ubuntu.
Ubuntu. Did she install the HDF5 package?
So I think she did the whole, this like long command that you have that installs everything. Do you then also have to do HDF5 after that?
That's not really everything, right? So there's
Oh,
this thing that installs all the dependencies, but then she should also do this. Did she do this?
No,
Speak loudly.
no, I did not.
So it's basically complaining that you don't have the HDF5 library headers because you don't have them. And you should have them before you can compile.
Okay,
Okay.
thanks. I can do that.
But this will install in a few seconds, so it should be quite easy to fix.
All right. Thank you. Great.
In the meantime, we successfully ran Smash, we ran Analyze, and now it's running Collect. And you can see we're done. So we now have successfully ran this example. So now in the example, you can also see that there is already a Mathematica notebook that shows you most of, or well, the interesting things from that example. So you can just run everything. You can see, so this is with with a relatively large number of events. Now we only ran 100. So when I execute this thing, all the error bars are going to explode. See, it's a lot bigger. So actually, let me undo that. Undo this as well. You can see here already a little bit. If you remembered what the actual plot looks like, you see that you have, going to smaller centralities, you have a dip and you have a rise. And this was computed on this laptop overnight. So like you can, well, it's not super clear, but you can see that there's a dip here. You can see a hint of this. So that's sort of how fast things are, that you can sort of see the relevant physics even if you're just running overnight on a laptop. So, and this is all these examples are constructed in a way that you should be able to just leave your laptop at the office when you go home and you come back in the morning and it's done. Depending on your laptop, of course. And also there's a function that allows you to print the logo into the plots. So yeah, that's basically it. So does the H5 now work in Joburg?
Sorry, Dory. What did you ask, Govert? Sorry, I'm like jumping between a bunch of people here. What was the question? Oh, did your thing work? What's the question?
No, I realized that I did run this.
Explain your problem.
No, it's still not working.
So after you've installed this, you do need to rerun the configure command.
Okay.
Yes, because that tells that creates a make-file with all the correct directories in it. So that configure file, that configure script, it finds the correct directory for H5 and then tells it to the compiler that is then able to use it. So that's, you do need to rerun that.
Okay, let me do that. Thank you.
So basically, aside from that, I wanted to have everything compiled before the end of the session, which maybe we'll manage for some of you.
I think I will.
Good. This is basically what I wanted to show you. So basically, how these parameter files work, how you can modify them. I mean, you can easily just modify the values. How to get the parameter files from every paper that we've ever written. How you can find them in the source code. And yeah, how to run an analysis. So for example, I've shown you this analyze bar file again, where you can just plug in exactly all the kinematic cuts that you want. So that's basically what I wanted to show you, and hopefully have you be able to do in the next 13 minutes. So is there anything specific that you guys wanted to know? So you guys work on jets.
Yeah.
So then you now at least know how to find the example that will tell you how to do this. I don't know much about how to then run Joule on this, but then Isabel knows that, so she can explain to you. So is there anything else that you guys are specifically interested in that you want to know?
How much do you need, just for that, would you say, the actual implementation of dynamics and stuff like this, going to
you can, I mean, it's open source, you can do whatever you want. The source code last time I counted was 70,000 lines. So it is it's relatively complicated to modify the hydro. Is that a fire alarm or?
Yes, but not just one of them.
Okay.
Probably lower.
I mean, how the hydro works is fairly complicated. So if you're interested, I can explain it to you, but it'll take me a large amount of time, as in like an hour or so. So not for now, but like
But how
later.
crazy would it be to do something more simple? I imagine, like, say, change the initial conditions or something like that.
Depends on what you want to change. If you want to make some minor adjustment, probably quite easy. If you let me know what you want to do, I can probably even point you to a specific line of code that you should change to do that. If you want to change it completely to something else, then it's more complicated. Again, it depends on what you specifically want to do.
I maybe wanted to know in terms of, I mean, I don't really know how it's implemented, but if I were, for example, interested in specific processes, like for example, we look at electroweak bosons. So if we're interested in events specifically where electroweak bosons are produced, is this possible in the context of Trajectum?
Not yet. I mean, we're working on making a hard sector that is functional. Unfortunately, the person I was doing this with left the field. Somehow the implementation of a parton shower seems to be cursed. So like every time we try this, the project just bleeds to death, and like no one actually does something. So well, I've applied for an ERC. I hope I get it, and then I get a dedicated postdoc who will be forced to work on this. But so yeah, electroweak bosons for now are not there. Hopefully will be in the future soon.
Because I mean, I also read your paper about the neutron skin, and you also mentioned that electroweak bosons can be an interesting
Yeah, it's more like that we wrote it down as in like we had the idea, couldn't work it out, so like put it in for future work.
Okay, I mean, obviously, we probably won't be, I mean, we do the experimental stuff, but, I mean, can a experimental measurement still be useful? I mean, if we do the experimental measurement, will there be something to compare to? That's
Not immediately, but then there are already some things that you can take into account when doing your measurement. So I actually gave a talk about this at the Alice Week. I don't know if you were there virtually.
was the.
Yeah, so basically what I said in that talk is like, you need to make sure that you do things in a way that we can reproduce.
Yes, for Bayesian.
Yeah. Well, I mean, for Bayesian analysis is especially important, but also more generally, like, right? If you want to compare theory to experiment, then you'd better do things on both sides that are sort of compatible with what the other side is capable of doing. Otherwise, well, you end up not being able to make a useful comparison.
Yes, yeah, that's why I'm curious. I mean, I don't think you can get it.
Yeah, that is understandable. Yeah, so this will take some work to implement. I mean, effectively, in terms of implementing things or implementing major things in the code, there's just me.
Yes.
There's some other people who do, for example, who implement one observable or make a minor adjustment, and then I make a pull request and I merge their code. But in terms of these major additions, it's basically just me who has to do all these things. So
no, I understand. Yeah, I'm not making a criticism.
No.
It's like
no, but also so that you understand that it's not like we have an army of people who can do these things.
No, I know. Listen, I think there's a problem with having human resources is prevalent everywhere. So
yeah,
well, it's tricky.
I also want to ask, in terms of the Bayesian analysis, is the code that you guys use for the Bayesian analysis also in Trajectum, or is it something?
It is in a separate repo. So in our private development repo, we have a separate repo for the Bayesian analysis. But the code is a bit of a mess. Well, I mean, we have everything in a private repo anyway, because like obviously people get nervous if their contributions are there for everyone to see. So basically what we do is we have everything in a private repo, which you can just join if you want, if you're interested. And then once every while, I just take a snapshot of the current state, censor out some things that people don't want public yet, and then I put that on out to the public. So this we've never actually published precisely because it's such a mess. So this basically really only works on the CERN cluster, and it takes quite a while to learn how to actually use this because it's like thousands of lines of code, and you could probably write it a lot cleaner and shorter if you put time into rewriting the whole thing. So yeah, you can of course take this and put it in your own cluster and then run a Bayesian analysis. But you would have to spend significant time getting it to work, and you would probably need my help doing that, which I'm happy to lend. But yeah, so if you want this, then and if you're serious about running a Bayesian analysis here, then we should probably get to work on this like today to get it to work by the end of the week, assuming you're good at coding.
Okay.
And you'd also need significant resources. So, for example,
yeah, how many hours? Oh, how many CPU hours do it take to do like say your?
So the neutron skin, for example, was 2 million CPU hours. Yeah, so that's like you really need quite a large amount of computation power available to do.
That's required.
I mean, lots of people are doing this. For example, I'm also talking to some of the people in Pakistan who apparently have a cluster that's just sitting idle, that at some point it was built for their CMS group who then didn't do anything with it. So they say like, ah, yeah, we're just like 5,000 cores that are just for them. So in principle, I told them like, yeah, I mean, it would take you like with that amount of cores, it would take you like a month to run a Bayesian analysis, but I mean, a month is not really prohibitively long. But then the electricity bill will still be quite large. So
5,000.
yeah, so I mean, it's
Maybe.
usually, I mean, I don't know if you have to pay for this, but like I know that for clusters, usually the biggest cost is electricity, and that one CPU hour costs about 1 euro cent. So like so it's like 20,000. A Bayesian analysis is basically 20,000 euros or US dollars, which, well, on most university budget it is not that much. I mean, I don't know about South Africa, but like, for example, in the Netherlands, that would be like one PhD student's salary for 6 months. So on the scale of, like, it's a lot of money, but on the scale of what you need to pay in terms of people's salaries, it's not like it's worth 10 people or something. So
My impression about the clusters is they also they prefer not to be sitting idle, but spend a lot of
yeah, of
money.
course. I mean, if you're paying for a cluster to,
Like it should be used, even if it's a marginal increase in the cost.
yeah,
It should be used.
yeah. So, but then, like what you're saying, like in the holidays, like
Yeah, like
at CERN, we also run in the holidays because the cluster's empty. So what we usually do is if we have a Bayesian analysis that we want to do and there's a holiday coming up, we make sure that it's set up before the holiday, and then we set it to run when no one else is using the cluster, and then it's done super quickly.
Yeah.
Oh, and you're also going to need a fair amount of disk space, which for us is actually a limiting factor. So we have 300 terabytes of disk space.
That's one.
It's almost always full.
How
You
much
really
how
need to
much
clean the site.
space is on the used in Bayesian analysis, actually?
So it depends. So how so I told you about the different steps. So for example, collide computes the events.
Right.
And then analyze basically just stores a bunch of numbers for each event that you will need.
Everything other than analyze is probably a lot faster.
Then it's a lot less. But if, for example, then you realized that that there's some reason why you cannot compare to the Alice measurement of something, and because for some reason you just can't, and then you need to switch to CMS. But oh, they're using different kinematic cuts. Now, if you've deleted the events, you can no longer change the kinematic cuts. So that comes with a risk. So it's obviously better if you can just save all of the events. But yeah, then that's a lot of disk space. So for example, a normal Bayesian analysis will usually be like at least 20 terabytes of disk space that you would need just to store everything. And not just Bayesian analysis, but like, for example, for this oxygen and neon paper, we ended up having, I think it was 5 terabytes of oxygen and 5 terabytes of neon in terms of events being stored on the cluster. So yeah, it really depends on what you want to do, but if you like it, and it depends on the statistics that you need, but like it's very easy to run out of disk space very, very quickly. Then again, this is also not very expensive. Like a 2 terabyte hard drive, you can buy for like 70 euros. So in principle, like they can probably get a bulk discount. So it's probably something like 500 euros to get you enough storage space to do what you need if it's not already available. I mean, what most clusters do is they have some huge amount of storage space, but then every user only gets like 1 gigabyte or something, or 10 gigabytes, because there's no use of giving everyone a huge amount. And then for most people, it's just going to be empty. So what most clusters do is they give everyone a small amount, and then you can get an extension of that if you need it. And then you probably have to motivate, like, I want to do such and such. And for that, I need so much disk space, and please give me that. And they usually do give you exactly that. So that's also how we got 300 terabytes from CERN. That, well, in that case, like they didn't give us 300 terabytes at once. You first have to.
You were running out of space.
Well, you first have to do something and like show them that there was actually a paper that came out of it and that was published and that it got citations, and then they're usually a bit more happy with giving you more disk space if they see it's being used for something useful. But yeah, I think the best advice is just to talk to a system admin or like someone who knows how your cluster works, to get set up, and to also ask what is available, like how much, like is it fair use? Can you just use as much as you want, or
Yeah, well, I mean, that's what we use. Well, we'll see the cluster. I mean, we've run a lot of stuff on the cluster, but like the typical, I mean, yeah, definitely wouldn't scale it to base in houses, right? You get like 250 cores. If I open it now.
well, you don't need a couple hundred. Oh, well, not a couple hundred gigabytes. You don't need a couple hundred terabytes to run your to refer your Bayesian analysis. Like 20 is probably plenty.
But 100 gigabytes.
Yeah.
But I mean, I could imagine. I mean, it's with. I mean, storage shouldn't be that expensive, I would think. But you know, like if you look on, you buy an SSD pretty cheap, quite a bit cheaper. But if I look, there's definitely a lot of empty clusters right now, like the holidays.
Yeah. Yeah. So
I wonder. I mean, is there some? I guess you have to recalibrate every single parameter every time you do one of these Bayesian analyses. Or is there some sort of middle ground where you say, like we're watching energy loss, so you tune some of the energy loss parameters, and you tune a bit of some of the, say, just the initial state or something.
So what you usually try to do is to, I mean, there's a trade-off, of course. Like the more parameters you vary, the more expensive it's going to be to do. So you want to somehow limit the amount of parameters, but also parameters can be correlated. And if you have a correlation between parameters and you're not actually varying one of them, but you fixed it, then you can get a bias. If you fixed it the wrong value, you get a bias on everything that's correlated with it.
Right.
So you need to have some kind of physics intuition of which parameters are absolutely necessary to vary, and which are not. So yeah, if you, for example, I can imagine if you want to do some kind of energy loss thing, for which you'd have to extensively modify this to be able to do that. If you want to do something like that, you probably at least need to vary something like the norm of how much energy is deposited in the initial state, because that correlates with the lifetime and the temperature of the plasma, which probably correlates very much with your RAA. So probably you at least have to vary that together with everything else that you're doing inside your your bottom shower. Because otherwise, if you just fix the norm, you're probably going to end up with a bias. So you just have to really think about things like that.
I guess you could get like, oh, it might look like you've strongly constrained some parameter, but it's just because these things are super correlated that you can fix one.
Yeah.
Basically fix the other.
Well, and also what is very important is that you also need to check that if you're basically doing a fit to data, that the data is actually being fitted, right? If you're that can also not happen because you fixed a parameter. Like that maybe it prefers to have a different value and then it does go through the data points, but you fixed it and now it doesn't, right? Stuff like that can happen, but then you usually only figure this out once you've already run the Bayesian analysis with a fixed parameter. So usually you just have to accept the fact that you're going to have to do the Bayesian analysis twice. So basically the first time you run it as best you think you can predetermine how to do everything, then you make notes of everything that you did wrong, and then you do it a second time. It's not how you should tell it to funding agencies, but in practice, that is how it works.
Yeah.
I mean, it's also like it's sort of an art, right? Like even for simple things that sound simple, like what should your prior range be? Well, your prior range should snugly fit around your posterior, but you don't know in advance what your posterior will be, right? So you have to make some kind of educated guess.
Yes, you know if you did it wrong, you'll probably see that. But...
Yes. I actually also have lectures about this that explain most of this. So if people are interested, I can go over this at some point. Which I'll also give next week.
So
yeah. How's the compiling going? So if you run collide, then what does it say? Oh, maybe points left going. Oh, you didn't install it. So yes, you should src/collide. Yeah, so if you go to the README, then usage. Yeah, so you need to, so in, I don't think this works for Mac. Mac has an insane default, which, well, it's not really default because you cannot change it. So it's just a setting, I guess. That library paths are often hard-coded in the executables, which basically means that, and then sometimes it gets it wrong. So if you, so you basically have to change those hard-coded paths of where the executables are, or where the libraries are, which I think is an insane setting because basically it means that you can never move these libraries around and things will stop working. Yeah. So we will obviously have to be,
Yeah, I was already like 10 minutes into the tutorial.
yes. Yeah, sorry for that. Well, I mean, not really sorry, it's easy for you.
Yes, yes, no, I didn't have to struggle with anything, so. Yeah, which is nice.
Yeah, for your Git problem, I really don't know how this is supposed to be.
Even very start. Should save PSL content package PSL that shape.
So you're compiling Trajectum or?
This is sample. It's not.
Okay, but GSL is installed.
Yeah, that shape.
You can check the known issues setting. This is the thing. Most of these errors that I've seen versions of it before. I can try this. Oh no, wait. Smash uses CMake. What does it say? It says it doesn't find the right version, or it doesn't find it at all. But you don't have young, right? So what if it's just oh, you do have young. Oh wait, but then did you? Oh, it says already installed, so it didn't really change anything. And what did you do exactly? Yeah, so what you basically need to do, I think, is to tell CMake exactly where this is, because it's probably not looking in the right place. So it's probably related to this. Well, I mean, I call this thing libraries installed in non-standard locations. It's probably that it's in a non-standard location, and you know it's installed. Yeah, but it's probably not in a place where Smash is looking for it. Yeah. Just check Did you manage to do this?
Yeah, I didn't change anything. Unless I need it.
Yeah, so you have the R paths. Yes, so you have the R path issue, which is the R path issue is that you exactly this, that library paths are hard-coded into executables. So what happened is that your executables have hard-coded paths of where it says it should find Pythia, but that's not where Pythia is. It's the wrong location. So you need to change this, use this tool to. So the easiest thing is to take all of these dilib files. So not just for Pythia, because once you resolve this error, you're going to get a different error for a different library. So just put all these errors, all these libraries in the same directory, and then just put that directory in the collide executable, the analyze executable, and the collide executable. Okay. And then once you do that, the error should go away.
And so and where they're in all of the ones in the these things, or
they're where you put them.
Yeah,
So the
okay.
Pythia ones are here, then the Gemini ones are going to be in where you compile Gemini, etc.
Installing virtual machine.
Also why I don't like Mac.
Oh, do you have a
Well, I'm an admin, so I can technically make a machine. But apparently there are no resources.
Are things going in Joburg?
I can't
Hi, Govert. We have several problems here. So we are okay. Wait, just two quick questions. One is we're still struggling with this H5 thing. So we did. It looks like the H5 is installed, but it might have happened that it's sort of installed in two different places.
On Ubuntu, right?
Yeah, on Ubuntu. So we did the thing, the long command, and then you run configure again. Yes.
Yes.
Yeah, and then if you do make, it complains that it can't find the header file still.
Maybe do make first.
Did you say do make first?
Maybe do make clean.
Make clean. Try clean. Try make
Maybe
clean.
some garbage is left from the wrong install from when it was not correct.
Oh, I see. Okay, now try make again.
I mean, it's more from my screen because it would be easier if I can look at your screen and see what's happening. But then once I
Yeah,
stop sharing,
exactly.
I cannot reshare because of this bug.
Oh, I see.
I can, well, let's just, and you share and
Yeah, so this is not 100% simple because she's not logged onto the call quickly. Are you able to just log into this call quickly? Okay, then there was a different issue. Well, I've got you. Okay,
oh,
Liam,
you've
I'm going to need you.
2 hours.
I'm sorry.
You've had me for 2 hours. You could have just yelled.
Yeah, I know. I didn't want to interrupt the physics discussion you were just having. Okay, so Liam is going to explain to you the problem he had because he installed Trajectum not from source. He used this other prepackaged thing. And
Yeah.
then now somehow the installation doesn't have of course, the source directory, right? So there's like where in the Trajectum folder, there's like examples and par files and stuff, but no source directory. So if you try to run one of the examples, it can't find the collide file, the collide executable.
Yes, that's correct. Yes. So what you should basically then do is that so it actually also says in the README to each example what you should do precisely. So if you don't
Oh, I see.
understand what I'm saying, then you should just read that. But it basically boils down to whenever you see, for example, in one of these files, you see point/collide or point/src/collide. You should just remove all of that and just replace it by just collide. Because for you, everything is going to be globally installed. So,
Okay.
so
Okay.
for you, just running collide without specifying where collide is located should just work. So you just
Okay, thank you.
scripts, and then it should work correctly.
Amazing. Thanks, Govert. That's amazing. Okay. Now, what's happening here? It looks like things are moving. Okay, good. That seems to have worked, the make clean. Good. Thanks, Govert.
Make clean did.
Yeah, that seemed to have worked. Yes? No. It's still making. We haven't run into the error yet, but we'll see. Yeah. Good. The rest of us are having more serious earlier problems, just like with Ubuntu, but that I think I can help out with.
You're all on Ubuntu, or
No, some are on Ubuntu and some are on, well, yeah, on these Linux subsystems. It's kind of funny because I managed to do this quite easily earlier this year. So it should work fine in the end. I managed to be able to do that. And then I have one person on Mac, but there's this is requiring some sort of installation of like C++ compilers and stuff that's like way before. It's not a problem you need to solve. I think I can solve that eventually. That's fine.
good.
Yes, thanks. And then we never managed to go through one of your examples that you were doing, but at least everybody's installing stuff.
In principle, the examples are all documented. So in principle, all the examples have a README that you can in principle just follow, and then things should work.
But Govert, we don't like reading READMEs.
I know most people don't like them. They just skip them and then run into issues and send emails.
Yeah. We'll try not to do that. We'll try not to do that. Just give me a second.
With the R path, how do you do? Can I have to manually go through one by one for every single dot thing, or can I do that whole path at a time?
Oh wait, I don't have the.
I copied them all in one place.
Yes, I think it was that if you copy them all to one place, you needed a slightly different command to the one that is written in the README. You basically needed to tell it to set. I think you needed to set RPath to a specific value to just that directory. But you can probably just Google this. It's a well-known issue. You know, what I had expected is like This is South Africa, and Ubuntu is from South Africa. So I expected lots of people with Ubuntu.
Yes. We would embrace Ubuntu and collectively use Ubuntu. No, it really wasn't.
Okay, Govert.
And our costs on.
I think that sounds okay. If Google says that your Stack Exchange says that, then yes, that. So Isabel,
Yeah, Govert, I'm still having problems with this H5. Okay. I almost
can you
feel like I
share the
want to-
screen?
Yeah. Offensive, please, can you log into this call? Oh, she's in the call. Good. Okay, share your screen. Sorry, I'm sorry. I'm losing my temper is short because I haven't eaten in a while. Okay. What? Down here? Yeah.
You
Okay.
can always just point your phone at the screen. I mean that always is an
I can do that
alternative.
as well. But she's sharing a screen now. Just click that thing, yeah? Okay. Okay, it's not that I just haven't eaten. I'm just hungry. It's not anybody's fault. Okay. Good. Can you see what's happening?
Yes.
Okay, good. So I will type, you will talk, and I will type. What do you want to see?
I think just do that.
From configure.
I'm sorry, you broke up a little bit.
So
more
when
time.
configured, I want to see that output. So just
Alright.
scroll.
So configure ran, let's see, I'm gonna go all the way up here.
Above.
Here we go. That's it.
Yeah, so here here you see that this didn't correctly run. So it didn't didn't. This is strange because when H5 is installed, then you already did with HDF5 equals that.
Yeah, so I tried to do that because I
Um,
found the HDF5 installation there. Sorry, one more time.
Can you remove that? Because I think previously you just didn't have this library, right?
Yeah. You want me to just do this?
Yes, because in principle, if it's in the default location, it should just find it. Yes, now it did find it. See, it got past the HDF5 libraries and it says yes.
Yeah, so this we did before. Okay, well, although maybe
Yeah, but this is looking good. This is looking exactly like it's supposed to. Yeah,
yeah,
so
this
now
looks like this.
so that you get rid of what you did before, make -j how many cores you have.
Very few.
And then you wait for a while.
I think I'll try to see Lotte this weekend if I can.
Yeah,
Seeing
nice.
as I missed her while she was here in Joburg. You see, here's this problem.
It still does this.
Yeah. I mean, maybe the thing to do is to uninstall H5 and reinstall it. Is that...
What's going wrong? I see what's going wrong.
Oh,
because,
do you? Good.
It's somehow trying to. Oh, Isabel, we had this problem before, didn't we?
Not that I can recall, but I believe you. Your memory is better than mine.
Here in the, you can see in what it's giving the G++ command, it's taking the HDF5 from Rivet.
Oh, we have had this problem before. If you install Rivet first. Okay, I've got it. Okay, I've got it.
We did have this before.
Yes.
With you. You had this
with me. You're absolutely right. You should not install Rivet first. You should always install Trajectum first. I actually do this on all my computers now. I always install Trajectum first because Trajectum is much more reasonable.
So you know how to solve this then?
I do know how to solve this. Perfect, 100%. What I'm going to do, I'm going to have Offense to do is uninstall Rivet, install Trajectum, and reinstall Rivet afterwards.
Good.
Yeah, that's it. Maybe you can put this into a known issues part in your README.
That is a perfectly sensible thing to do.
Because lots of people use Rivet. But then, of course, you have to do this in a way that doesn't make the rivet people feel silly.
That will be difficult.
That's okay. They deserve to feel silly.
I mean, I think that the issue was that rivet. Can you maybe at some point send me a message before I write this known issues?
No, yeah, absolutely.
Because
What
it
do
was
you want
something rivet overwrites this HDF5 file, right? So that it basically replaces this file with a broken version. And that then oh yes, that's what it was. So that basically when you install Rivet, it overwrites this H5CC file that is supposed to set everything to the correct thing, and then overwrites it pointing to a broken version, so that then configure when it runs picks up the wrong version and starts pointing to that, and then you get these errors.
Oh, that's so wild.
I think that's what it was. Yeah.
Yeah, I actually completely forgot about this because then I found that I've always had trouble installing rivets. Installing rivets, I even like tell all my students you should prepare for several weeks of pain to install rivets. And then afterwards I found that if you install Trajectum first, even if you're never going to use Trajectum, somehow the rivets installation goes smoothly.
Okay, that is strange.
It's much faster to install Trajectum first and then rivet than to just try to install rivet.
Okay.
Yeah.
But yeah, it's noted that I should make this known issues section or entry into
Thanks,
the known.
Robert. Thanks for
Um,
get that very much. Also, the other person that went smoothly, everything's working fine there. And then I will see what's happening with my other. I have 2 people doing this Windows subsystem for Linux thing.
yeah, that should be the easiest way to do things.
Yeah, actually, I think the main. Yeah, I think that is probably the easiest. Yeah. Good. Thanks, Robert.
Great.
You can stop sharing there, I think.
So then on your side, everything is things that you can handle. Can you? You're muted in case you're talking. Well, it's pretty fine. So pretty go to lunch, I guess. Yeah, so in case you can still hear me in Joburg, we're gonna go to lunch. Just let me know if there are any other issues.